Now let us come to this question number 6 of exercise 13.1. The question says, a small indoor greenhouse herbarium is made entirely of glass panes including base held together with tape. It is 30 centimeter long, 25 centimeter wide and 25 centimeter high. What is the area of the glass? The second part is how much of tape is needed for all the 12 edges. You see, this is the case of that greenhouse where L, B and H is given. We have to calculate the area. Each side of it is made up of glass panes which are held together by tapes. Tape at this place, at this place, at this place, at this place, and we make a structure like this. This is the question. So without understanding it, if we are doing, then we will have some problem. So it is better that we first understand the question. Question is this. Now here we see the dimensions are given. 30 centimeter into 25 centimeter into 25 centimeter. So we need to first part is very easy. We need to calculate the TSA. So what is the TSA? TSA we know this is 2LB plus 2H L plus B. So from this we calculate this 2 into L 30 into B 25 plus 2 into H 25, this 30 plus 25. So this is 60 into 25 plus 50 into 55. So this is 1500 plus 2750. If we add these two, 2750 052, this is coming as 4250 centimeter square. This is okay?
Yes.
So this is the first part of the question which we have done. We have calculated TSA. We know this is the TSA. We know all the dimensions. We put the values and we get the answer as 42. I am writing it in bold font so that this is visible in video. So this is 4250 centimeter square. Now come to the second part. Now coming to the second part of the problem. How long tape is required to hold these glass panes together? We see this figure and we are able to understand that there are 6 glass panes, one here, one at back. So pair of these two, pair of these two, pair of these two. So these 6 glass panes are held together with the help of tape. Tape is put here, tape is put here, tape is put here. At all the edges, tape is placed, tape is pasted so that this structure of glass pane is held together. So from this we can see one tape is required to be placed here, one tape is required to be placed here. Similarly, on back of it also, one tape is required at this place, one tape is required at this place. Along this width also, one tape is required at this place, one tape is required at this place. its opposite side, along width, one tape is required to be placed here, one tape is required to be placed here. Along height, one tape is required to be placed here, one tape is required to be placed here, one tape is required to be placed here, one tape is required to be placed here. So we can easily say the length of tape will be 4 into L plus B plus H. L plus L, again here L plus L, so 4L. B plus B, this B plus this B, 4B. Then this H plus this H, this H plus this H. So along all the edges, we need to put tape. And we know the dimension. So 30 plus 25 plus 25. 50, 60. 50 and 30. 80. So 320 centimeter. This is okay?
Yes.
Coming to 7th problem of exercise 13.1. Santi Sweet Stall was placing an order for making cardboard boxes for packing their sweets. Two sizes of boxes were required. The bigger of dimension 25 centimeter into 20 centimeter into 5 centimeter, and the smaller of dimension 15 centimeter into 12 centimeter into 5 centimeter. For all the overlaps, 5% of total surface area is required extra. If the cost of the cardboard is rupees 4 per 1000 centimeter square, find the cost of cardboard required for supplying 250 boxes of each kind. Whenever we visit a sweet shop, we see that based on our requirement of sweets, different size of boxes are given. Same way, this Santi sweet is having two kind of boxes, bigger box and smaller box. For both these kind of boxes, the dimensions are given. So what are the dimensions? The dimension is 25 cm into 20 cm into 5 cm. Here the dimension is 15 cm into 12 cm into 5 cm. Dimension is given. So from these dimensions we can calculate the TSA by using the formula 2LB 2H L plus B. So this is L, this is B, this is H, this is L, this is B, this is H, which all of us know. So upon calculating, putting this LBH for bigger box in this, we will get the TSA of bigger box as
1450.
1450 centimeters square. And putting the value of TSA in, putting the value of the dimensions of a smaller box in this formula, we will get the TSA of a smaller box as
630.
630 centimeter square. This thing we are doing in all the questions, so we can easily do. There is nothing more to write on it. Now this area of one big and one small box will be how much? 802. This is, so this is the area of one big and one small box. Now 5% extra area is needed because some of the cardboard is wasted in making the overlaps for holding the sides together, which we all of us see in case of any box of cardboard, paper, etc. Either it should be pasted or there is a kind of overlap which hold the two faces or the same face in some different fashion so that it is held together. So for that calculation 5% extra area is required as per the question. So we calculate the 5% extra area. So this is 2080 into 5 divided by 100. So this is coming as 104 centimeter square. Now this is the extra area which is required. So the total area of one small and one big box was 2080. Now that extra area which is needed, we add this up in this area to know the area of one big and one smaller box, considering overlaps. Will be how much? This 2080, which was the sum of the TSA of this and this, plus 5% of this, which is coming at 104. So this is 2184 centimeter square. This area we require to consider the overlaps. Now the rate of making the box, that is the cost of the cardboard, is given. Cost of cardboard is rupees 4 per 1000 centimeter square. And the area which we want is 2184. So if we multiply these two, we will get the cost. So cost will be 2184 into 4 divided by 1000. Okay. One thing. Then this area is the area of one big and one small box. We need to multiply it with 250 boxes which are needed to be made. So we multiply the total area. We should calculate the total area. This is the area of one big and one small box. We multiply it with 250 because 250 boxes are to be made. So the area of one big and one small box is needed to be multiplied with 250 quantity. So this is 4. So this is rupees 2184. And this amount we require for obtaining the cardboard. This is about the 7th question. Okay, now come to the 8th and the last question of exercise 13.1. The question is, Praveen wanted to make a temporary shelter for her car by making a box-like structure with tarpaulin that covers all the four sides and the top of the car, with the front face as a flap which can be rolled up. Assuming that the stitching margins are very small and therefore negligible, how much tarpaulin would be required to make the shelter of height 25 meter with base dimension 4 meter into 3 meter? Praveen wanted to make a tarpaulin cover for her car, and the dimensions are given, length, breadth, height is given, and in case of the front face of the car, it is given that the front face is also made in such a way that it is rolled up in the front. So the tarpaulin is made in the size of a box. When it is made in the size of a box, it's a case of cuboid and the dimensions are given. So the dimensions are 2.5 meter into 4 meter into 3 meter. This dimension, this is L, this is B, and this is H. This dimension is given. This tarpaulin sheet is used to make a box-like structure to cover the car, and dimension of LBH is given. It is also given that stitching margins are very small, so we do not need to calculate anything on that. We just consider the LBH and do the calculations. Extra margins and other things we need not consider. Then it is important for all of us to know that what the question said, that it covers all the four sides and the top of the car. So it's a box-like structure in such a way that it is covering the top of the car and all the four sides. When it is covering top of car, so we are solving the 8th question. I have wrongly written the dimension because the dimension is given as base dimension 4 meter. Base dimension is 4 meter into 3 meter, and height is given as 2.5 meter. Base dimension. Base dimension means L into B. Base dimension means L into B. So this is L, this is B, and this is H. So now we will calculate, and this tarpaulin sheet, which is made in the form of a box, covers the top and the four sides. So the area would be the area of the top, that is LB, plus the four walls means the lateral surface area. So this will be the area which is required to be covered. So LB 4 into 3 plus 2 into 2.5, L plus B 4 plus 3, so 12 plus 5 into 7, so this is 12 plus 35, that is 47 meter square. So this is the area is coming as
47 meters.
47. It is okay.
Yes.
So what else? What else, Manvi? What else is
Nothing.
required to be calculated?
Nothing else.
Nothing else. Okay.
Only this.
So this is all about the
area.
This was the only thing which was required to be calculated. Only area was to be calculated. So this area is 47 meter square. This is all about this 13.1, and I hope I'll be able to clear it and give you an insight how to handle these questions, and thank you.